Thank you for coming. I do want to point out these names here on the slide. Those are my fellow researchers and co-authors, the people that I've worked with on this project. So, Dr. Cooper, Briggs, and Holliday. So really quickly, I'm just going to give you an outline of what I intend to talk about. First, I'm going to go over the project, what we do. Then I'm going to describe the quantitative instruments that we used one by one and give you the results for each of those. And I'll do the same for the qualitative instruments. Then I'm going to talk about some current and future ideas, things that I think I've learned from these measures, and then I'm going to try to apply going forward. And I'm also keen to hear what you think about any of this stuff. So a quick project summary. This is a 2-year quasi-experimental study conducted with 3 instructors. In a given semester, we all taught the same way. And so we're talking about 4 semesters. It was control, treatment, treatment, control. So on the slides that I'm going to show you later, where I'm giving you means and standard deviations and things like that, it'll typically be the 2 middle bars that will be the treatment groups. Just so you know. So what did we do in the actual classroom? Well, we gave out packets, 4 to 6 pages of definitions and problems for them to start working on, things like that. They were supposed to work on these things outside of class. That was sort of the expectation. But we did also have time in class where they would work together in small groups. In some sections of the class, we actually had these miniature dry erase boards that we would pass out. And they would get together around a dry erase board, 3 or 4 students around a dry erase board, and do that. And we had some groups that said they really enjoyed that, and they liked that. And then the next semester, we handed out the dry erase boards again, and they said, what are these for? We're like, so you can work together in groups. And go, why can't we use paper? Well, you can use paper, but we thought the dry erase boards being so, different would make it somehow better. And they're like, now we'll just use paper. Okay, so, but we tried to make them a little comfortable in class with group work and things like that as well. Typically, they would present their solutions at the board, even if they worked in small groups on the dry erase boards or on paper. We still called students up to the board to show what they were thinking about or what they had done to everybody else in the class. So how do we motivate them to actually participate? Well, of course, we gave them a participation grade, anywhere from 20 to 30% of the class grade, depending on the instructor, what we decided to do. There were also in-semester exams that had questions on them that were noticeably similar to the questions that were in the packets. We want to see what you're learning. So we just wanted to try to help them out. They were motivated by both the desire to earn those participation points as well as to basically earn a good grade in the class. All right, so really quickly, let me explain that this was actually a follow-up study to a previous 1-year study, 1 year, 2 semesters study. And in that study, we adhered much more closely to Moore's original idea of what this Moore method would be. We asked them not to consult any textbooks. We didn't use WebAssign for online homework. We did say, don't go to the tutor lab. Inside the math department, we have a tutor lab that's like right down the hall from where we teach our classes. So in that, this was like 4 years ago now. Those students have all graduated. But we said, hey, you're in this class and there's tutors right down there. Don't talk to them. And they didn't like that. So this study, of course, we decided we were going to loosen those things up a little bit. They were allowed to work in groups, as I said, and we brought instructor summaries gradually more and more into the course. So let's see, what are some of the rationales for these departures? First of all, we don't have the option anymore at our institution to not adopt a textbook for a 1,000 level class. That's what this is. This is a pre-calculus class it's a first-year level class. So we have a standard adoption that comes with WebAssign. we decided that we would just embrace WebAssign. That's part of the course. They get a grade for that. It's extra practice outside of class. We decided that that could be beneficial to the students, and so we went with it. We said that Tutor Lab's right down there. We think it's beneficial to you if you work on these problems alone, work on them yourself. But we won't consider it cheating if you visit the tutors. You're cheating yourself, but we won't report you to academic integrity or anything like that. And group work was also allowed as well. And what we mean by instructor summaries, instead of when we would finish a set of problems that were all kind of related, all leading to a major result, instead of just going, very good, okay, who has the problem, who has the answer to number 87? We would pause in class and say, okay, now those problems were very good. And we would discuss what we hoped the students had learned, try to summarize it for them a little bit, which, as I said before, in the one-year study, we didn't really do that. So we thought that this was hopefully a little better for the students, but we'll talk about what we've learned from some of those things later on. All right, so what were some of the measures that we used in our study? We gave them a pretest to look for existing mathematical ability, and the joke is that we found none, but that's not true. But I'll go into explaining what we did find. And we also gave them a survey on teaching style preferences, both at the beginning and the end of the semester, same survey. We had a common final exam, and one of the researchers involved, Dr. Cooper actually, conducted in-person interviews. Some students were randomly selected for in-person interviews. Not all students were interviewed, but all students were given an opportunity to respond to an open-ended survey. Open-ended survey with prompts that were similar to the prompts in the interviews. So here's our pretest. As you can see, it's a little bit of mostly trigonometry and a little bit of functions. There's this finding the inverse and solving this exponential thing, right? So we just wanted to see, do they already know this stuff? Because that would be kind of important. If we had a group that came in already making a 10 out of 10 on this pretest, then what would be the point of what we were trying to teach them if they already knew it? Turns out they didn't really already know it all that great. The means were, here they were for all 12 groups, all 12 sections. The means are 206, 274. Do you see them there? The only one that's only slightly higher was for instructor 1. The mean of 3.21 was significantly higher than the two lowest scores. And it wasn't even significantly higher than the 2.74. So there you go. And for instructors 2 and 3, they were all about the same. So we used the ANOVA and Tukey's and all this other stuff. So I'm gonna be throwing some stats type stuff at you. If you have any questions about exactly what I mean there, I'll be happy to answer anything like that. The teaching preference survey, let me explain what that was. Prior to the current study, so between the one-year study and then the follow-up 2-year study, we had some time when we didn't actually have a research grant going on, but we were still thinking about these kinds of things. So we actually developed, we cobbled together a survey that we thought would help us understand if our students preferred teacher-centered courses over student-centered courses. And we ended up with, after we did an exploratory factor analysis, we knocked it down from 30-some questions to just 28 questions, 14 that preferred teacher-centered activities, and 14 that preferred student-centered activities. So we had 2 subscales, and the subscales hang together pretty well. If you know what a Cronbach alpha is, anything above 0.7 is considered pretty good. If you start getting close to 1, then everything on your survey is, you're just asking the same question 7 different ways. If your Cronbach alpha is a 1, then they're perfectly correlated, and you only need 1 question, not 7 questions. But 0.8, 0.78, those are okay. And these were Likert type questions on a scale from 1 to 7, that kind of thing. And here you go. So we constructed 2 different variables that we thought were kind of measuring the same thing, but they both have their uses for us, from our purposes. One we just called the IBL preference, and it was a simple sum. We added up the student-centered questions, and we reverse-coded the teacher-centered questions and then added those together. So that the higher your score, the more open you were to IBL methods in class. We also created SCMTC or SC minus TC, which could go negative. And what I liked about this was we had a really bright line, 0. You know, if somebody was fully teacher-centered, they would have a negative score, and the further negative their score was, the more teacher-centered they felt. Okay. So the summary here, again, at the beginning of the semester, we didn't see a whole lot of differences, except there's one thing that's really weird. Spring of 14, the most recent semester, all of those students were extremely teacher-centered. They wanted to be lectured to. Don't know what's up with that. But they were actually lectured to. This was a control semester. They got traditional style lecture. That's what they got. That's what they wanted. They got it. Okay. We also looked at the post just to see if there was any shift. The same trend is sort of there. It was only the spring semester that was significantly different from the other 3 for each of the 4 instructors. And then we did match pairs or dependent sample t-tests. But this ended up being 12 separate t-tests, right? So we do have these 2 fairly low p-values, but 12 separate t-tests. We're running a pretty good chance of having a spurious outcome here, committing a type 1 error. So we used the Bonferroni adjustment. And with that, only this one's really significant. All right. This is one of the ones where I just wanted to throw this up here just so you could see it really quickly. The difference between student-centered and teacher-centered questions. You see they're all negative. Our students, on average, these are means that I'm reporting here, on average, our students wanted to be lectured to. And these p-values are all significant. I'm only covering the first year because you don't need to see, this big, long chart that's got all basically the same information, a column of zeros on this end. So every class seemed to prefer being lectured to, if given the option, apparently. If given, when asked in the form of a survey, if they wanted to be lectured to, they said yeah. All right, so let's get down to kind of the meat and potatoes a little bit here, the final exam. We had 20 multiple choice questions, 8 free response questions. Mid-study, we did change things up a little bit. 1 multiple choice question was added, a free response question was replaced, and another one was just flat out dropped. All right, but then these variables that we named, are these composite variables, MC and FR, those are the number of multiple choice questions that they got correct of those multiple choice questions that were in common. And FR is the number of points earned from the free response section only for those questions that they all saw. Okay, so anyways. The sort of good news is that for the multiple choice section, there's really no significant difference between any of these. They're all about the same. The ANOVA, the p-values for the ANOVAs right here, 0.2, 0.86, 0.17, or 0.18, I suppose, if I'm rounding. There's no significant difference. So what's the takeaway? Well, I feel like the takeaway is that if you want to use IBL techniques in your pre-calculus class, your students aren't going to learn any less, right? There's no argument there that they can learn less necessarily, at least not from the point of view of these multiple choice questions. It might be kind of hard to argue that they would learn any more too at the same time, but let's move on to the free response questions. All right, so the free response results are a little complicated. All right, so here are the means and standard deviations for all the sections for all 3 instructors. And you do see an upward trend here, a dip down followed by an upward trend again. These were pretty stable. That's kind of cool but kind of weird at the same time, the stability that's there. Using ANOVA to see what's going on here. For instructor 2, as you might have guessed, no significant difference, all the same. But for instructors 1 and 3, ANOVA did reveal a difference, as you probably also guessed. And the post hoc analysis showed us this. The green circle are things that were essentially the same, or at least not statistically significantly different. And so this is different from this. Similarly, this is different from those pairs. So these two are roughly the same, and that one's significantly higher than them, but not significantly higher than the 36.7 that's right there in the middle. All right. So for that particular instructor, there's this weird upward trend over all 4 semesters. Remember, these are the same questions all 4 semesters on the final exam. So, and for instructor 3, the only difference is that the first treatment semester is significantly lower than the other 3. So this is also a treatment semester, and these 2 are control semesters. Semesters where the students received traditional lecture, chalk and talk, we call it. All right. But here's something that we found. We were kind of digging around in the numbers trying to look for something interesting, something positive to say. And here's what we noticed. Here's one thing we noticed. For the treatment group only, when we looked at whether or not the students had a positive or negative point of view when it came to student-centered methods, what we found was that the students that had a tendency to prefer student-centered methods, so they had a positive SC minus TC score, they did significantly better on both sections of the final exam. So the treatment section, of course, those are the students that are receiving inquiry-based learning in class. That's how they were taught. So they got what they wanted, and they did better on the final. We also looked at some qualitative data. Of course, what I mean here, these are the answers to the free response survey. And as you can see, all the students were asked to complete an open-ended survey. Some of them did not turn it in. 17 students from the IBL sections were interviewed. Really quickly, how do we choose who to interview? Because that could be important. That would be a potential entry point for bias in our study here, right? We passed out a volunteer sheet. Students were randomly selected from amongst those who volunteered. Students were offered a small incentive to volunteer, the equivalent of 1 in-class presentation's worth of extra credit. So that's like, if they really did the math, they'd realize it's like half a percentage point on their course grade. But I guess a lot of them probably didn't. I had classes where all of them signed up, every single one of them. Just as something I wanted to point out maybe I'm only amusing myself at this moment, but a policy at our school requires that if we offer extra credit as an incentive for participating in an educational study, we have to offer an alternative form of extra credit for students who choose not to participate in the study. In this case, we said you have to write an essay on the life and accomplishments of R.L. Moore. I didn't get any of those essays turned in. Students did not want to do that. So anyways. So one of the first questions on the survey and also during the interviews was, did you like the teaching style used in this class? As you can see, overwhelmingly the traditional students said yes. And the IBL students, well, on paper form they said no. And in the live interviews they tended to say, well, they didn't want to hurt our feelings, I guess, face to face, I don't know. But in the interviews they expressed mixed feelings, and we thought maybe that might just be them trying to tell us what they know we want to hear, but at the same time, they really didn't like it, so they weren't going to outright lie. So here's some actual quotes from the surveys where students wrote their answers. So in response to, did you like the teaching style in this class? Why or why not? A lot of students said something about the level of guidance. The traditional students up here said that they liked the level of guidance in their lecture classes. They liked it. Here are some of it just works for me. Good lectures equals good notes equals good grades, so on. The IBL students did not necessarily like that. By the way, level of guidance was not a prompt. That was that's a category for the type of response that Dr. Cooper got to the question, why or why not? Why didn't you like the style of class? And so we got these kinds of answers to that question. I just do better when someone is explaining it to me and giving me examples. Those are the kinds of quotes that the students gave us. Math does not come easy for me. I need teachers to show problems in a step-by-step fashion, and on the problems that I'll be tested on. So, anyways. Some of them cited the level of difficulty. Now remember, most of the traditional students said they did like the class, and the reason they liked the class was because it was so easy. All right? And the Moore method, or the IBL students, said they tended to say that they kind of didn't like the class, or they had mixed feelings about the class, and it was because they thought it was hard. I had no idea how to solve any of the problems, and I felt like I was falling behind in class more than any other class or course. Alrighty. Amount learned. The traditional students said they felt like they were learning a lot, but remember, the final exam results were, well, the free response questions, the results were a little bit complicated, but the majority of the final exam was that multiple choice section, 20 questions. The traditional students didn't demonstrate they had learned all that much more than the Moore method students, right? But the traditional students said they felt like they were learning more, and the IBL students sort of said the opposite. They felt like they weren't learning as much. Right? Now, I think of this as being that the IBL students, maybe because of what they were getting out of the class, they were seeing that there was more to math than just solving a few little problems with logarithms and trig functions. But I don't know, maybe they just felt like this class was kind of hard. But I actually feel like that's kind of okay. College is supposed to be a little hard. A little hard, not impossible, not an unscalable mountain, but it's okay if you struggle and finally, through perseverance, are successful at something. That's okay in college. It's probably okay other places too. What are some of the qualities of... Okay, so another thing that the students said was that they felt like maybe they just weren't gifted at math. That IBL might be great for math people, but not necessarily good for everyone. So here's some other questions that we asked. How many math classes have you taken in the past that used a similar teaching style? The traditional students tended to say all of them or most of them. And the IBL students tended to say none. They hadn't seen this teaching style ever before. Maybe they hadn't. I don't know. It's probably not used extensively in high schools. These were incoming freshmen, most of them. This was a freshman level course. When we asked them what they thought the strengths and weaknesses of this class might be, they typically repeated back to us the reasons why they didn't like the class. Right? So a lot of times the strengths and weaknesses were the same sorts of things. Interestingly enough, the traditional students cited that they liked that they had opportunities to participate in class. Opportunities that were kind of specifically denied them, but they thought that they had great opportunities to participate in class. And oddly enough, the students that really were encouraged to participate in class, only 4 of them noted that as a strength. Another thing that actually we did work on a little bit, this was where the enhanced instructor summaries kind of came from, was the feedback from the students that they didn't feel like they learned all that much from watching their classmates present. I don't know why, but part of it, some students were like, well, what if they're presenting wrong? I only want to halfway pay attention in case the solution's wrong. I don't want to absorb incorrect information. So I would like to wait until the problem's completely done and then find out from you if it's right or not. And then I'll look and see if it's worth copying down. Okay, maybe. Another thing they said was that they tended to focus on the problem that they knew they were hoping to present. They worked on their problem. They would pick I'm gonna present problem 12 before the next class. And they would work on that problem exclusively. And they weren't listening to the explanation for problem 11 when it was presented right before theirs. Okay. How much effort did it take to succeed in this class? Actually, they said about the same, because we asked them to compare it to other math classes they'd taken. They said that they didn't work any harder in this class. So, I mean, that kind of flies in the face of the earlier claim that it was too difficult, but okay. Maybe some of them thought it was more difficult. But anyways. Wait, that's not, sorry, I got that reversed. Over half the students in both groups, but in both groups, the traditional students and the IBL students said it required more. Sorry, I got that reversed. Only a small number of them said it required less. But anyways, I think the conflict here in my mind was that the traditional students previously said that this class was easy, and the IBL students said it was hard, but then both groups said it required the same amount of effort as any other class they'd ever taken before. So it's kind of like, well, how does that work? Alrighty. How much did you learn in this class? Again, the traditional classes said that they learned more or a lot, whereas the IBL students felt like they didn't learn quite as much. But keep in mind, they did equally well in the multiple choice section of the final exam. So I don't know. I use that as my measure of what they learned. Seems like they were doing okay. What factors influenced your participation? The most common response was that they were participating because they knew it was worth their grade. It was part of their grade. That's fine. I would like them to participate because they enjoyed working on the problems. Anyways, I've got some ideas about things I might do later on to try to bring them along there. Another common response was that they either did or didn't present because they lacked confidence about the correctness of their solution, or they were really sure it was right. So what's next for me? I kind of believe in IBL methods. I think that they can be used properly, and that the students can benefit from using them. Throwing out, sorry, I'm not using IBL methods because my students say they don't like them. Like I said, it seems like throwing the baby out with the bathwater. But I do think I need to be responsive to what the students are saying about exactly what they do and don't like, and try to I don't know, mitigate some of these concerns for them. Something else that I'm definitely going to do is I'm not going to hand out any more consent forms at the beginning of the semester, as is required by our IRB when we're doing educational studies like this. We have to hand out a consent form, and the students think that they're consenting to the class itself. I'm like, no, you consented to the class itself when you registered for it. Right? Now, I can teach this. I could teach this standing on my head if I was physically capable of doing that. The consent form is just so that I can use your data in a study. All right? But it's a little like the whole changing the outcome by measuring it, or not necessarily changing it, but influencing it. I'm doing other things in other classes that are using an IBL type technique that I'm not including in any kind of study, and the students don't get a consent form in the beginning of the semester, and they don't have this weird negative attitude about it the whole time. Something else that I'm doing, if I didn't mention it before, we started off with Ted Mahavier's trigonometry notes, which are available from GIBLM, the Journal of Inquiry-Based Learning in Mathematics. Go online, download lots of really good course notes there. They have notes for proofs courses, other kinds of classes as well. So we started with those, but our pre-calculus class includes advanced algebra topics like exponential equations and logarithms. So those were authored by one of the researchers in this group. So we added to those. But we've also, each of us has revised our notes based on what we're seeing our students needing in class. And one thing that I definitely have done, I've added close to 30 new questions just in the last semester, providing what I'm calling scaffolding here. Smaller connecting problems that move them from one to the next. or breaking an existing problem into several parts so that they can move through it a little bit more smoothly with a little more guidance. I also include some fun problems in there that are maybe things from discrete math. Actually, one of the questions that's in there is a 9 coin, one of them counterfeit, that was just like the Starbird's example last night, where you have a balanced scale that breaks after 2 uses or something like that. So one of the problems, so I've got like, I think close to 20 of those thrown in there just for fun. And I actually started the semester off with, I've started doing team building exercises, things to kind of break the ice, make them feel more comfortable in class. All right, so any questions or suggestions or ideas? And thank you.